When dealing with extremely long electrical runs to a farmhouse, particularly distances exceeding 1500 feet, voltage drop becomes a significant concern, necessitating careful consideration of available options. A 500 MCM wire might initially seem necessary to combat voltage drop, but exploring alternative solutions can potentially offer more cost-effective and practical outcomes. Here are several approaches to mitigate voltage drop and ensure a reliable electrical supply. Firstly, consider pad-mounted transformers. Placing a transformer closer to the new house reduces the distance the 500 MCM wire needs to travel. This can prove a cost-effective solution, but it necessitates excavation work and the installation of a concrete pad to accommodate the transformer. Secondly, think about pole-mounted transformers. Instead of a pad-mounted transformer, a pole-mounted transformer can be installed on a utility pole closer to the house. This option generally presents a low-cost alternative compared to pad-mounted transformers, and it involves less excavation. However, its feasibility depends on the presence of existing utility poles in the vicinity. If poles are absent, this option might not be viable. Thirdly, assess the possibility of a high-voltage line extension. Extending the high-voltage line to the vicinity of the new house represents another solution. While typically the most expensive option, extending the high-voltage line provides the most stable voltage over long distances. It ensures a consistent power supply, minimizing voltage fluctuations. Fourthly, investigate the use of underground wiring. Installing the electrical service underground using direct burial cable can reduce voltage drop compared to overhead wiring. Although more expensive than overhead wiring, underground installation offers enhanced protection against environmental factors and potential damage. Fifthly, look into voltage optimization equipment. Installing voltage optimization equipment, such as capacitors or regulators, can improve the voltage supply. These devices actively regulate voltage levels, ensuring a stable and consistent power delivery. Sixthly, consider distributed generation. Generating electricity on site using renewable sources, such as solar panels or a wind turbine, reduces the demand on the electrical grid and mitigates voltage drop. This approach not only provides a sustainable energy source but also enhances energy independence. Seventhly, negotiate with the utility. Contacting the local utility company and discussing available options can be beneficial. They might have specific requirements or programs tailored to assist with long-run electrical services. Engaging with the utility can provide valuable insights and potential cost-saving opportunities. In addition to these options, several other factors merit attention. Conducting a detailed voltage drop calculation is crucial to determine the actual wire size required. Accurate calculations ensure that the chosen wire gauge adequately addresses the voltage drop concerns. Consulting with a licensed electrician is essential to ensure the design and installation comply with all applicable code requirements. A qualified electrician possesses the expertise to navigate complex electrical systems and ensure safety. Considering the potential future load requirements of the house and oversizing the wiring accordingly prevents future electrical limitations. Planning for future expansion avoids the need for costly upgrades later on. Obtaining the necessary permits and approvals from local authorities before proceeding with any work is mandatory. Compliance with local regulations ensures that the project meets safety standards and legal requirements. In summary, addressing a 1500-foot-plus electrical run to a farmhouse requires a comprehensive approach that considers various factors, including voltage drop, cost, and feasibility. By carefully evaluating the options outlined above and consulting with qualified professionals, a reliable and sustainable electrical solution can be achieved. Remember to prioritize safety and compliance throughout the design and installation process. Consider these different approaches, which include pad-mounted transformers, which can be placed closer to the house to reduce wire length and subsequent voltage drop, but this requires excavation and a concrete pad. Next is pole-mounted transformers, which are less expensive and require less excavation, but may not be suitable if there are no existing poles. And also high-voltage line extension, which provides the most stable voltage but is generally the most expensive. Do not forget about other factors such as underground wiring using direct burial cable, which reduces voltage drop but is more expensive than overhead wiring. Voltage optimization equipment such as capacitors or regulators can be used to improve voltage supply. Also, distributed generation using renewable sources like solar or wind can reduce demand on the electrical grid. And of course, you should always negotiate with the local utility company to discuss available options and potential programs. Remember to conduct a detailed voltage drop calculation to determine the precise wire size, consult with a licensed electrician, consider future load requirements, and obtain the necessary permits.